Alright, so picking up where we left off there, we have we're looking for dw dt, and so since w is a function of v, we had to take the derivative of both sides with respect to t, and using the as a related rates problem, using the chain rule, we eventually came up with dw dt is equal to negative 3.536 v to the negative 0.84 dv dt. And we found that since the wind velocity is increasing at a constant rate of 5 miles per hour, well, that's dv dt. So we can replace that with 5, and we ended up with negative 3.536 v to the negative 0.84 times 5. So we'll pick it up from that point here. And so the first thing I do is multiply that negative 3.536 times 5, and I do get negative 17.68 v to the negative 0.84. Now what I need to find out is what is the velocity at time t equals 3. And I have that written over here. V of 3 is equal to 35. Now how do I know that? Well, the velocity starts at 20 miles per hour. So at time t equals 0, v is 20. At time t equals 1, we know that the velocity is increasing at a constant rate of 5 miles per hour, so v of 1 is going to be 25. v of 2 is going to be 30. v of 3 is going to be 35. So in the end, what I'm looking for is negative 17.68 times 35 to the negative 0.854. So since negative 17.68 is my current answer, I can just multiply that. Clear that. I'm going to multiply negative 17 times 35 to the, and I want to put this in parentheses, negative 0.84, and that gives me negative 0.892. And the units for that will be the units of W, which are degrees Fahrenheit, divided by the units of T, which is hours. And that should be the correct answer there. So let's step back and take a look at this from another direction. We know that we're looking for dw dt, but w is a function of v, so we'll have to take the derivative of w with respect to v, and then multiply that times dv dt, because that will give us dw dt. Now once again, we've already stated that dv dt we know to be the rate at which velocity is changing is 5 miles per hour. It increases at a constant rate of 5 miles per hour. So we're told that the wind velocity increases at a constant rate of 5 miles per hour, so that is dv dt is equal to 5. Now we're looking for dw dv when t is equal to 3, not when v is equal to 3. So since the velocity is dependent upon time, then we have to find out what the velocity is when time t is equal to 3. We've already done that. We said that v of 3 is equal to 35. And so dw dv when t is equal to 3 is the same thing as w prime of 35. At time t equals 3, the velocity of the wind is 35, so we're looking for the rate of change of the wind chill with respect to velocity when velocity is 35. And that's kind of a parenthetical thought there. So now we're going to put that back together, and what we're really looking for is w prime of 35 times 5. So if we bring out the calculator again and go back to our functions, well, we have y2 is w prime of v. And so if I just turn off everything else and graph that, now I'm not looking for this is w prime already, so I'm just looking for a value here. I'm not looking for a derivative. So I'm going to do second calc value, which is option 1, and plug in 35, and it gives me negative 0.178. And I go back out to the main screen, negative 0.178 times 5 equals negative 0.89. Now I really needed that extra decimal place in there, and I must have cut it off at some point.